a microservice processing order, events kept crashing with OOM-Killed every 30 minutes, despite a 4 GB RAM limit. The culprit? An unbounded subscriber buffer combined with RIDI's pub/sub backpressure, consuming 3.8 GB before the kill. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover publish-subscribe pattern. The publish-subscribe pattern is a messaging paradigm where publishers send messages to topics without knowing which subscribers receive them. Subscribers express interest in topics and receive messages asynchronously, decoupling the sender from the receiver. Direct coupling between services creates fragility. If service A calls service B directly and B is slow or down, A fails too. Pub/sub breaks that chain. The publisher doesn't care if subscribers exist or are healthy. It just fires a message and moves on. Here's a basic example. The order service publishes an order-placed event. The notification service sends an email, and the inventory service decrements stock. Both subscribers receive the same message independently. This code shows a publisher and two subscribers. The publisher sends a JSON message to the order's topic. Both subscribers listen to that topic and process the event. Note: never trust message payloads blindly, always validate schema on the subscriber side. Your broker choice defines your failure modes. Kafka is built for high-throughput, persistent, replayable streams. RIDI's pub/sub is fast but ephemeral. Messages are lost if no subscriber is listening. RabbitMQ sits in between, persistent queues, flexible routing, but lower throughput than Kafka. Here are code snippets for each broker. Kafka uses a producer and consumer with offset management. RIDI's uses publish and subscribe commands. RabbitMQ uses exchanges and queues. Each has different trade-offs. The most common pub/sub failure is the subscriber falling behind. Messages pile up on the broker, memory grows, and eventually the broker OOMs or starts dropping messages. This is backpressure, and you must handle it. This subscriber uses a bounded buffer of 1,000 messages. When the buffer is full, it pauses the subscription and alerts. Messages that fail processing are sent to a dead letter queue. Always monitor consumer lag as an early warning. Most pub/sub systems guarantee at least once delivery. That means your subscriber will see the same message more than once. If you're not idempotent, you'll double charge customers or create duplicate records. This subscriber uses a RIDI's dedup cache. It checks if the idempotency key exists before processing. If it does, the message is skipped. The TTL should be longer than the maximum retry window. Not all messages can be processed. If you keep retrying forever, you'll clog the queue. Enter the dead letter queue, a separate queue for messages that failed after a maximum number of retries. This RabbitMQ setup configures a dead letter exchange. After 3 retries, messages are routed to the DL queue. Always monitor DL queue depth. A growing DL queue means something is broken. Pub/sub is not always the answer. If you have a single consumer and need a response, use a direct call. If you need exactly once processing, consider a transactional outbox pattern. Avoid pub/sub for low latency interactions. For a simple email notification after registration, a direct HTTP call with retry is simpler and cheaper than setting up Kafka. Use pub/sub only when you need multiple independent consumers. The Kafka consumer example uses commit sync, which is available in Kafka 0.9+. For older brokers, use commit sync map or commit async. Also note that enable auto commit equals false is required for manual offset management. Otherwise, offsets may be committed before processing completes. The article mentions RIDI's pub/sub is ephemeral. For durable pub/sub with consumer groups, use RIDI's streams. This snippet shows a publisher and consumer group subscriber that supports backpressure and message acknowledgement. The article mentions monitoring consumer lag, but doesn't emphasize that lag should be monitored per partition, not just overall. In Kafka, a single slow partition can cause lag even if other partitions are fine. Use Kafka consumer groups describe and alert on max partition lag, not average. Pub/sub systems are notoriously hard to debug because messages flow asynchronously. You need end-to-end tracing. Attach a unique trace ID to every message at the publisher and propagate it through all subscribers. This code attaches a trace ID to every message and logs at each step. This allows you to correlate publisher and subscriber events and debug missing messages. This is the same issue we highlighted at the start. Here's exactly why that happened. The subscriber was using RIDI's pub/sub with a blocking BR-pop. When the RIDI's broker couldn't keep up, messages buffered in RIDI's memory. The subscriber's client library also had an unbounded in-memory buffer of 10,000 messages. Combined, they consumed 3.8 GB before OOM. The fix was to set a maximum in-memory buffer size on the subscriber, e.g., 1,000 messages, configure RIDI's max memory policy all keys LRU, and add a circuit breaker to pause subscription when the buffer exceeds 80%. This prevents memory exhaustion. An unbounded buffer can cause the subscriber to consume all available memory, leading to an OOM crash. Always bound your buffers. This is the exact code that caused the incident. The unbounded push allowed the buffer to grow until memory ran out. Always bound your buffers. If your broker retries for 30 minutes, a 5-minute TTL will allow duplicates. Set TTL to at least 1 hour to cover the retry window. Don't use pub/sub to implement RPC. You'll end up with correlation IDs, temporary reply queues, and timeouts, a poor man's HTTP. Use a proper RPC framework instead. Here are the first response commands for debugging pub/sub issues. Check consumer lag to see if subscribers are falling behind. Check memory usage for OOM risks. Monitor queue depths. Let's run through some common interview questions. How does Kafka handle backpressure? It buffers on disk. Consumer lag grows, scale consumers. When choose RabbitMQ over Kafka, for flexible routing, lower complexity, no replay needed. What happens when Kafka consumer crashes? Offsets committed after processing, at least once. Use idempotency. And a few frequently asked questions. What is pub/sub used for? Decoupling event producers from consumers across services. Difference between observer and pub/sub. Observer is in process. Pub/sub is cross-process via broker. Is exactly once delivery possible? Extremely hard. At least once plus idempotency is practical. To recap, pub/sub enables a sync, scalable communication but adds complexity. Always bound buffers, implement idempotency, use dead letter queues, and choose your broker wisely. Ready to go deeper? Up next, Kafka and the distributed log, then MapReduce and batch processing, then stream processing. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.